So far, we've been looking at a graph, translating the behavior that we can see to different calculus-based statements or algebra-based statements. Now what we want to do is use some algebra or calculus-based statements to construct, to sketch the graph of a given function. We can start off with some of the, I would call it the easiest information, which is just the XY coordinate pairs. In this case, we'll go ahead and add some values to our X and Y axis. And we know that we have a point occurring at -2, -4, 0, 0, 2, 4, and actually those are the only 3 points. So we can start off by plotting those 2 points. Next, in my mind, I would consider this end behavior information, which tells us that as x approaches infinity, our function is headed to -infinity. So whatever else is happening, our curve has to be heading down here. And as x approaches -infinity, our function is approaching positive infinity. So I can sketch in what that end behavior should look like. Now we can look at the first derivative. Our function is increasing, that is, our first derivative function is positive, on the interval from -2 to 0, and from 0 to 2. Our function is decreasing from -infinity to -2, and from 2 to infinity. So I'm just plopping in some arrows to kind of give myself sort of a general format for how this curve is going to go. It's starting to take shape, but the next piece we need to know is how our function is curving from point to point. And we can do that using the second derivative, that information about concavity. Our function is going to be concave up from -infinity to 0. So our function is going to be doing something like this. And our function is going to be concave down from 0 to infinity, so our function needs to open down. And eventually we have enough information that we can start to sketch what our curve should look like. This doesn't have to be super precise, but we should be able to hit each of those points, and we should have the general idea down of which direction our function is opening in, where it's increasing, where it's decreasing. We're not given any specific values about where intercepts occur, but as long as we can plot this curve in blue, we have something that resembles something that is a sketch of that function. In example 8, we want to do the same thing, but we have different information that's provided to us. Starting off by just plotting our coordinate pairs is a relatively easy place to start. In this case, we have points at 0, 2, 1, -3, 3, 5, and 4, 4. Every piece of information that we plot or sketch out a little bit just starts to help us see the picture. Next, we can look at end behavior. In this case, as x approaches infinity or -infinity, our function value is approaching 3. That tells us that we have a horizontal asymptote at y equals 3. And that our function needs to be approaching that asymptote as we head in each direction. We also have some information here about asymptotes, because we're told that as we approach 2 from each direction, our function is either headed to positive or negative infinity. The only way that behavior can happen is if we had a vertical asymptote, and this tells us as we approach 2 from the right-hand side, we're headed to infinity. As we approach 2 from the left-hand side, we're headed to negative infinity. We're told that our function is decreasing across the entire domain except at that point 2, where our function is undefined. So our function has to be decreasing. We're told that our function is concave up on the interval from 2 to infinity. So we need to follow a curve that's opening up, and our curve needs to be concave down from negative infinity to 2, so our function needs to be opening down. So we're going to end up with a curve that's opening up and decreasing, approaching that horizontal asymptote and that vertical asymptote, and then a function that's approaching that horizontal asymptote, decreasing and concave down as we approach that vertical asymptote. And again, what we're after is this line in blue, this curve that sketches the graph of what this function should look like, or what a function would look like if it had these particular characteristics.